Hey, math friends. For our learning target today is that I can find the volume of a cylinder. So again, the geometry stuff in 7th grade always has something to do with circles or cylinders. That's pretty much the only learning target that we have in geometry, in the geometry category. So you absolutely will need a calculator today because we'll be doing a lot of calculator entry. So cylinders, we'll talk about a cylinder. Well, a cylinder is like a pop can. So to build it, you have two congruent circles, and then you basically have this rectangle that wraps around it. Now, no judgment there, but that's the idea of a cylinder. So you basically are going to cut a rectangle, roll it into the tube, and then you have a circle on top and a circle on bottom. So those are the three shapes that we use to build a cylinder. So that's how a cylinder is made. And we're talking about volume today. When we talk about volume, we're talking about capacity. Like how much does the cylinder hold is what we're asking about, the capacity. So for the formula for volume of anything, just any 3D figure, there's a formula that works for any 3D figure. The thing that you need to know is the base of the figure. So you could use it for a prism, a pyramid. Of course, pyramids, we'd have to, change that volume a little bit. That's a whole nother lesson. But we need to know the area of the base. So the measurement for the volume of the cylinder specifically is that we're going to find the area of the base, which happens to be a circle. Find the area of the base, and then we simply multiply it by the height of the cylinder. So really, those are the only pieces that we need to know. So this capital B really means area of base. And we know that the base of a cylinder is a circle. And we know to find the area of a circle, pi r squared sounds like area to me. And then we multiply that by the height. So that is the formula that we need for today. The formula that I have given here in the middle of this page, that works for any 3D figure. Find the area of the bottom of the figure and multiply by the height. All right, so let's take a look at our first example here. The formula for volume of a cylinder is you take the area of the base, that stands for area of base, not the base. So this big giant capital B means area of base, times the height. So the area of the circular bottom is measured by pi r squared, sounds like area to me, and then we'll just multiply it by the height. So like I said, you need a calculator today because it's basically calculator entry work. So 3.14 times the radius of the circle. The radius of the circle would be 5. And then we multiply by the height of the circle, which is 10. So this is your big capital B, your area of base, and then multiply it by height. So we have 3.14 times 5 squared times 10. So type it in, which gives us 785. The unit on that is feet. And we're talking about volume. Since it's a 3D figure, how much does this hold? How much pop does that can hold? It's cube. So 785 feet cubed to the third power because it's three-dimensional. And where we get those three dimensions is we have the radius, we have the square of the radius, so really radius times radius, and then we're multiplying that by the height. So there's your 3 dimensions, radius times height. Pi is just a constant, right? So we're just inputting that 3.14 for pi. We approximate it, but so that's the volume of the first cylinder. How much pop does it hold? Boom, that's how much pop it holds. Next problem, same idea, but this time I'm going to give you the diameter. Now, when you see the arrow in these problems, ignore the arrow. I always thought this was really confusing. And look at the line. So ignore that arrow because I think it gets kind of confusing. So let's just talk about what we have here. That means the diameter is 8. So the radius would be 4 plus 4, right? The radius would be 4. And the height would be 12. Just maybe some helpful information there. So volume is measured by the area of the bottom times the height. And the bottom, of course, is a circle. So the area of the bottom is always going to be, for cylinders, pi r squared sounds like area to me. And then we just multiply it by the height of the cylinder. So we have 3.14 times the radius. Radius there we said was 4. The diameter was 8. The radius is 4 squared. And the height is 12. So we are simply just going to input that into our calculator. So we get 3.14 times 4 squared times 12, which gives us 602.88 inches cubed. Third power again. So we're talking about how much does this cylinder hold? How much can we fill it with? The volume is 602.88 inches cubed, the volume of that cylinder. If I'm going too fast, go ahead, pause the video. Otherwise, we're going to keep moving on. Third problem for today on volume of a cylinder. Now, this is a can that's just simply kicked over. So don't be confused about that, about the height of the can. The height of this can is still 15. It doesn't matter that the can is just simply kicked over. The radius of the can is 4. So the diameter would really be 4 plus 4 would be 8. So there's just some helpful things in case we need them. Volume is measured by capital B times H. And capital B we know is the area of the base. So that's pi r squared times height. So the volume of the cylinder is pi r squared times height. So as we start to solve then, we get that it's 3.14 times the radius, which is 4, squared, times the height, which is 8. So the volume of the cylinder is 3.14 times 4 squared times 8. Type it in, type it in, type it in. I'm going to work at my pace, but I need you to actually attempt these, right? This is your learning journey, so make sure you're attempting these. Just simply pause the video, type them in, and then verify that you got the right answer. How much does this can hold? It holds 401.92 feet cube of whatever it is, whether it's sugar or pop or anything. Green beans comes in a cylinder and things like that. Okay, so moving on. Just by looking at the two cylinders, which do you think has the greater volume? Explain your reasoning. So go ahead and pause for a minute and just think about, do you think it's A or do you think it's B? Which has the greater volume? So which has the bigger impact on volume? So this has a radius of 3, that has a radius of 2. This has a height of 4, that has a height of 9. So which has a bigger impact on the volume of a cylinder? The radius or the height is kind of what we're thinking about. So let's go ahead and calculate the volume. The volume of A would be pi r squared times height. The volume of B would be the same formula. I'm going to move this just so I have a little more space. The volume of B would be pi r squared times height. So as we plug in then, we have that the volume would be 3.14. The radius is 3 squared times the height of 4. Calculate volume. Over on the other cylinder, volume is equal to 3.14. The radius is 2 squared, and the height is 9. Multiply. Do it, do it, do it, do it. Calculate the volume of each of those. Volume for the cylinder A and volume for the cylinder B. If you need to pause the video, do it. Looks like I don't have any units, so we're just going to go ahead and say units cubed. Units cubed, whatever it happens to be, feet squared, whatever. Or feet, centimeters, whatever. And then cylinder B, Whoops, I made a mistake on that first one. That is not correct. You should be catching that. That is not correct. I typed in the wrong height. Boo. So 3.14 times the radius squared times the height. Oh, maybe I did do that right. I guess I did do that right. Oops. I think it's the next one that I got wrong. So 113.04 units cubed. Okay. So now let's take a look at the other one, the B. So that's 3.14 times 2 squared times 9. Oh, I guess I did get the same answer. So now let's go ahead and take a look at which did you think was going to hold more volume? Did you say A? Did you say B? Or did you say that they would be the same? So what ends up happening, and actually that surprised me a little bit. I wasn't anticipating that happening, that they have the same volume. The thing that has the bigger impact on the volume is the radius, and the reason why it does is because the radius is squared. It has a bigger impact on volume than height does. So that is a big idea behind when you find volume. That radius has a big impact because it's really radius times height. All right, so volume of a cylinder, we're going to do one more and then we'll be out. So this problem is our last problem of the day. How do we calculate the volume of a cylinder? Again, ignore that arrow because I do think it gets a little bit confusing. Look at the line that's given. All right, so we'd say that the diameter here is 6, which means the radius is 3, and the height is 18, just for some stuff that we might need as we start to solve. Volume is equal to capital B times H. So we get pi r squared times height. So the volume of the cylinder then is equal to 3.14 times the radius, which is 3, squared times 18. So how much does this can hold? So the volume of that cylinder would be 508.68 meters cubed. Again, make sure that you're getting that. You should be pausing the video before you listen to the answer, right? So that's the volume of that cylinder. So for our learning target today, we talked about that we have a cylinder made up of 3 pieces. We talked about in order to find the volume of that, it's capital B times H of any 3D figure. A volume of a cylinder has a circular base, so then that becomes pi r squared times height. So essentially all you have to do is get the area of the bottom, pi r squared, and then multiply it by the height. That's your learning target for today. Have a glorious night.